Hello, everybody. In this video, I'm going to do the stack implementation, okay, using an array. So if you think about it, what is a stack? A stack is a data structure that can hold objects, right? And the characteristic of a stack is last in, first out. So if you put something onto the stack, the last one that's put in will be the first one to be popped. So the pushed one is on top, and the popped one will be the top one. That's the characteristic, and you have no way to access the middle elements or any other elements. So to do that data structure, to do that abstract data type, that collection, that's the external view. Externally, a stack is something you can only push to the top and take off from the top externally, right? But how do you make this structure? It's like when you design a car, you think, okay, a car can only drive, it can only reverse, it can only brake, etc. But how do you internally implement those? How do you make it so? So for a stack, how do we internally implement this collection, this data structure? An obvious choice is an array, right? Because array has indices, each element is at a certain position, and the indices are consecutive from 0 to 1 to 2. So an array is an obvious choice. Now let's look at an array. Suppose this is an array, okay? Let me see if I'm recording. Yeah, I am. Okay, this is an array. It's called, the array's name is stack, okay? And this array's size is 6, right? So this is position 0, 1, 2, 3, 4, 5. When we push it to the first position. Let's suppose we push a character A there, okay? And then we push again, we push a Z, that should go to 1, right? And the next available position to have an element is 2. So we push a C, and then the next available position to store an element should be 3. So from this, you can see the next available position is always one more than the current top, right? The current element at the top. And also, when you pop, when you take an element off, that element is always one less than the next available position. But from the next available position, in this case, it's 3, we can get to the current element, which is at position 2. And also because of the characteristic, the property of having the entry point and exit point as one point, that means they are the same. Your entry and exit, it's one point. So we only need to keep track of one position, one point, which is the next available position. So we can name it top. Currently, top is 3. Okay, once again, we only need to keep track of this one position because entry and exit are roughly the same, right? So our current position, next available position is 3, and we name it top. Because it's a position, it's an index, so this top should be an int. We are not keeping track of the actual element, not the actual element, no, but the position, the available position. So it should be int, and currently it's 3. So if you want to push something, you will put it into 3, okay? If you want to put a question mark there. And now after that, you should change your top, add 1 to it, now it should be 4. Okay, if you want to pop something, then you should go 1 down because this is always an empty position. That's always the empty position. That's the next available position. So if you want to pop, you should go 1 less than that current position, which is the top element. So if you go down, if you pop, you go one down from top. That is top minus minus, right? So you use this one variable and you can keep track of the top, the next position to be pushed to, and the element to pop, to take off. And to peak, it's the same, right? And so that's that one, one entry point and exit point. We use a top to remember it. Another thing you need to remember is now this is an empty array. And what is our top? Our top is 0, right? That's the next available position. And how many elements are in this array? 0. So how many elements are in this array? 4. That's our top. So your top has 3 functions, really. It remembers the next available position when you push something. You can use it to get to the top element. When you pop, right? You just do top minus, you know that element is at top minus 1. And top also is the number of elements in the array. Basically, it's the size of that stack, of that array. So given that, I hope you understand all that. Now let's go back to our implementation. Okay, let's look at the implementation. So first, I want to discuss this exception class, okay? The exception, as you can see, I have a folder for it. And this is the this is the class, right? I have it here. Okay, you always extend exception or runtime exception. Actually, stack exception is a runtime exception. We discussed this because it's when you pop and the stack is empty, you throw an exception. When you push, there will never be an exception because you are supposed to be able to push forever. It should never be full. So this is really for when the stack is empty. And so it happens at runtime. And that's why I'm extending runtime exception, okay? And you have 2 constructors. One accepts a string, a message, your catered message. One is just, I'm just saying the stack is empty. So that's the exception class. Let's look at the interface, okay? The interface. So you remember we discussed a client, when you use a stack, you are really looking at the interface. You interact with the actual implementation through the interface. So the interface gives you the methods you can use. And here we have these methods, right? Public void push. And remember, this interface accepts a generic type. That means the stack is a container. It can hold any elements of a generic type, okay? And when you actually create that container, you decide what type it should be. Okay, so push. When you push, remember, you are supposed to be pushed to the sky. It can never be full. The stack can never be full. And that's why its return type is simply void, because you don't even have to tell me if you are successful, right? You are just putting things onto the stack. So it's void, it's not even Boolean. And when you push, you accept a generic element, okay? And when you pop, there is a possibility of throwing an exception. So your pop method declares that it throws stack exception. And it gives you back, you remove it, and you also return that generic element. So the return type is T. And peek is the same thing, except it does not remove the element. It only peeks at it, it only looks at it. Okay, return it, but does not move it. Size gives you the number of elements in the array, in the stack, and it's empty is whether it's empty. And toString, you make a string of all the elements on the stack. Okay, that's the interface. And now let's look at the array stack. That's the implementation. So for the array stack, you need to import the stack exception. Okay, this is the name because a stack can be implemented in different ways, and this implementation uses an array. So we are calling it array stack, and it accepts, why do I have two? Okay, it accepts a generic element, and it implements stack interface, which also accepts generic elements. So that all are matched, right? They are matched. And just now we discussed this top, this instance variable, right? So for a stack, you need to keep track of the exit point, the entry point, which are just one less, right? Just it's a one difference. The next available position and the one below it. The one below it is the one to be popped. The top is the one to be pushed, is the position to be pushed to. So we keep that one variable, okay, to keep track of the position to be popped and the position to be pushed to, and the size of the stack. So that's the one variable. It's a position, so it's an int. And now here we declare an array, and we don't know what you want to hold in the stack, so we make it a generic type. So it's a generic typed array here, right? And we name it stack. You can name it anything, but stack is more meaningful. And this is something that's a static variable default cap. That is, when you declare create a stack, you can specify the size. You say, I only have 20 elements, so I want 20. Or you can say whatever number, I don't care because it can never be full anyway. So I am giving it a default size 3. I make it specifically very small so that it's easier to test, right? So, okay, that's a variable. And now this is a constructor, okay, that's a constructor. This constructor accepts a size. That's what I said. If you want to say, I want to create a stack with 15 elements, then you will give it 15, right? Pass that 15 to size. And whatever size you give me, I use that to create this stack, to instantiate the stack. So I'm going to explain this a little bit. Let's look at this. Because this stack is a generic element, right? It's a stack of generic element. So why can't we just simply say this? New T size. Can we do that? And you can see there is an error. And it tells you cannot create a generic array of T. Why? Because T is just a placeholder. It does not exist. If you look at data types in Java, T does not exist because it's a generic type. It's a placeholder. So you can actually not create this array. The compiler doesn't recognize T. So how do you get around this? Okay, and this is how. We instantiate an array of object. This is okay. The compiler will recognize that, right? But it still doesn't work. This part works. But when you assign that new array to stack, it doesn't work. Why? Okay, let's see. It says unchecked cast from object to T. Okay, the reason is stack is a T type, right? It's a T type. And this is an object type. So you need to cast it back to T. And that's why we put this here. Okay, we say, okay, cast it. Oh, not there, here. We say cast it. What do you cast it to? Cast it back to a T array. Okay, now it works. So that's how this works. And this is, at the beginning, when you create this stack, it's empty. So your top is 0. There is no element. And also remember, your constructor is to initialize all instance variables, right? So these are the 2 instance variables you need to initialize. Okay. That's a constructor. And this one, this is an overloaded constructor. It accepts nothing. That means when you create a stack, you don't have a specific number in mind. So what does the system do? The system will use this keyword to call the constructor there. So this references the current object, right? So this is calling this constructor and passing 3, the default cap, to size, okay? And basically it will run this code with 3 as the size. Okay, so that's this constructor. And some of you may say, okay, you may not ask that, but you can simply do this actually. It's equivalent to this, and instead of size, you put default size there, right? You put the default size 3 there. So you can do that and comment this out, but because this constructor is done and you don't want to repeat the code, and you also want to appear very professional and very capable, so you use this syntax, which is really a wonderful syntax. Okay, that's the constructor. So this allows you to create a stack if you have a specific number in mind. If you don't, you are okay. The system will still create a stack for you. Okay, that's these 2 constructors. Now let's talk about push. Okay, to push, we already discussed the void, right? You don't need to tell me if you're successful or not. When I push, it should always go to the stack, and you accept a generic element. If stack.length is equal to top, expand capacity. Okay, stack.length, this is the number, the length of the array, right? And top is the next available spot to push an element at. So let's look at this again. Okay, this is messy, but currently for this one, the length is what? 6. Stack.length is 6, right? 6. And the top currently is 4. So are they equal? No. That means you can still push. So if you want to push an element, you want to push an equal sign, then just put it there. And then you increment your top, now it's 5. And then they are not equal, 6 and 5 are not equal, so you can still push, right? If you want to push, what do you want to push? A Y, you just push Y there at that location. And now your top should be 6 because you need to always have the next available spot. So now it's 6. Now they are equal. Your top and your stack.length are equal. What does that mean? That means your array is full. And look at it, your array is full, right? Because there are 6 elements and top is 6. So now what do you do? Once it's full, okay? What do we do once it's full? Once it's full, we will expand the capacity. What does that mean? That means we will increase the array size, okay? Expand capacity is a private method. And now let's look at this. Here it is, expand capacity. Let's see how this works. Okay, expand capacity. We will declare a temporary array, call it temp, of type T, right? And we use the same syntax, you understand that. But here our size is stack.length multiplied 2. Basically, we double the array size. So let's go back here. This is stack, that's our array. And now we will create a new one. I was too close to the edge and call it temp. Okay, this is temp. And we double the size. Currently, it's how many? 6, right? The size is 6. We double it, then it should be 12. So we should have one more. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That way we doubled it, right? And so that's what this does. We double the size. Can we triple? Can you triple? Yes, but you might be wasting a lot of spaces if that's not used, right? So to be safe, we double it. And then we use this for loop, okay, this for loop to copy each element in stack into the new temp array. So we use a for loop. You can see that's a for loop to go through everything, stack.length, which is 6, okay? So I is less than stack.length, right? So we copy this one here, A. We copy this one here, Z, C, and then question mark. This is an equal sign, and this is Y. Okay, we copied it here. And that's what this does, this array, this for loop. It does that, right? We copy it. And the last statement, after we copy, we do stack is equal to temp, which means temp is assigned to stack. What does that mean? That means temp currently is pointing to this array, right? And you are saying stack is assigned whatever temp is pointing to. So that means stack is pointing to this array. Originally, stack is pointing here, but now, no, it's pointing to this array. The array temp is pointing to. Okay, so now stack and temp are aliases. They point to the same location. However, when you exit this method, when you exit the method, this expand capacity, okay, temp is gone. It's a local variable. It automatically is destroyed when you exit the method, but stack is forever. Why do we need to do this array assignment? Because stack is the variable we recognize that is used throughout the implementation, that is recognized by all methods. It's visible to all, while temp is a local variable that's only visible to expand capacity. And upon exit, it's destroyed automatically. So we assign temp to stack, and then we don't care about about temp anymore, right? So now our stack is pointing to this location. That variable is destroyed. It doesn't mean that memory location is. That memory location is pointed to by stack. Okay, so that's out of the way. We are done with this part. So now it's easy. Our top is what? Remember here, our top is 6. So now if you want to push a U, then you just put it in 6, okay? So stack top equals to element. And that is, your top is 6. Now you put your U there. And now your top is 7. And if you push, it will go to 7, right? And there are 7 elements here. That's the number of elements in your array, okay? And top plus plus, we did that. After you push it to 6, we increment it to 7 so that we have the next available spot ready for push. Okay, that is the push method. Now let's look at, we discussed expand capacity already, right? Let's look at pop, okay? Pop. So when we pop, we want to take an element off the stack, and it's always the last element that's pushed. So now let's pop. If we want to pop, remember, the element is always 1 less than the current top, because top is always empty. It's always the available spot for the next element. We think about the future. So top is empty. And if you want to pop, it always is the one below top, which is 1 less than top, right? So top is 7, and the one you want to pop is at 6. And so what do? First, you want to see if it's empty, okay? How do you know if it's empty? You know it's empty when your top is 0, right? Because your top is 0 when you initialize it. That's when it's empty. If you don't do a push, it's empty. Okay, so if it's empty, then you throw an exception. and it exits, right, from pop, and nothing will execute. But if it's not empty, we want to pop. Remember, when you pop, you need to return the element, which is a generic type. So we declare a local variable ready to store the element we want to return. And then we do top minus minus. Okay, so currently our top is 7. We do top minus minus. Now it's 6, which is this location. Okay, and then we can get that top, which is this one. We assign it to result. Okay, we assign it to result. And this is still there, but it's not useful anymore. That's why we do this. We set it to null. So when we set it to null, it's not pointing to anything. So, oh, eraser. Why does it not work? Oops. Oh, I erased everything, everybody. That's very sad. What did I? Oh, here. Okay. I was trying to erase that, but it seems it doesn't work. Okay, it works. So we set it to null, which means it doesn't point to anything. Okay. Actually, you have to remember these are objects. They are not directly in those positions, right? They are in another place. Those positions are storing the pointers, but I'm not going there. I want you to visualize. So now we set it to null. It's not pointing to anything. To vacate that location, and then we return that result. We give it back to whoever called pop. Okay. That is the pop implementation. And the key to remember is you need to decrement top so that you get to the element. And now your top is 6. And guess how many elements are there? Right? There are 6 elements. See? That's the number of elements in the array. And when you push it to 6, which is empty. So you can push it there. That is this implementation. And then peak is exactly the same as this one, except you don't decrement top. You know the element is at top minus 1, but you do not actually decrement top because you are not removing anything. You are just peaking at that element. And that element is at top minus 1, right? And you return it. So your top is intact. That's your peak. And size, we already discussed that. Top is your size. If top is 0, it's empty. So if top is 0, it's empty. That's the other method. And string, okay, let's look at toString. Among these implementations, toString is the most difficult one, the one that needs you to think. So when you implement the toString method, what you do is to give me a string representation of all the elements, right? And each element will take care of itself. Each element will have its own toString method. So you simply call that element toString method. That's easy, but you need to concatenate them. So if you look at this stack, okay, how do you implement the toString method? The toString method will return a string which should start with the last element because a stack is a last in, first out. So when you return me a string, it should be Y $? C Z A. That's the string you need to return. So you need to start from the end, not the beginning, not the string AZC ? Y. That would be wrong. Okay, you need to give me a string starting from the top to the bottom. That's something you need to remember. Another thing to remember is that your top currently is 6, right? But your actual element is at position 5. And so you know that's top minus 1. That's the position you need to start, right? I said it. Okay. And also make sure you do not use top to loop through the array. If you use top and decrement top, then you will be decrementing top until it's 0. And then the next time your stack will be empty because your top would be 0. Okay, so after you call the toString method, call it again to see if it still prints out the same string. Call it twice to test your implementation is correct. I would say use a temporary variable to loop through the string. Initialize it to top, and then use that temporary, initialize it to top or roughly top, I would say roughly top, and use that variable to loop through the array. Okay, you do not touch top. Remember, you do not touch it because it remembers the last position, the position to be pushed to, and it's also the size of the array. So you do not touch it, you use it. That is this implementation, everybody. I will do another video for the driver, otherwise this is too long. So I will stop here.